Hello people, I'm Bharat Acharya. Welcome to our new video. So, what are we doing in today's video? We are going to do 8051 programming. So you'll be like, whoa, so what's new? We've already done 8051 programming. Of course we have. What we had seen was programs written on the board, right? Today, we're going to be writing the programs on the computer, the way you do it in your practical exam. I'm going to show you how to use an EdSim simulator, the most popular one. That's most colleges use the same one. And we're going to enter programs, run, check the result the way an examiner will do it in the practical exam. I will show you how to enter different inputs and still check your result, whether your program works in all conditions or not, how to check the flags, how to check the ports, etc. We're going to start with a simple program of add two numbers, move to, subtract, multiply, divide, the regulars, the starting programs. And then we're going to move to complicated ones, finding the highest number, sorting a series, the kind of programs that we haven't even done on the board so far, and many more. So this is not going to be just one video. Starting from today, I will be making a series of videos on practical programming, including interface programming, programming with the matrix keyboard, programming with the 7-segment displays, programming with A to D converter, D to A converter, waveform generation, etc. So many students are good at programs in the theory paper. They can write programs. When you teach them in the class on the board, they understand programs, they dictate programs by themselves. But the moment they go to the lab, they just don't even know how to start the simulator, how to even make a simple program like add two numbers work on a simulator. When somebody says, okay, show me the values of flags, they don't know where to look. That should not be with you. May happen with others, but not with my students. So let's get on with it.
Learn now how to download and install the EdSim application. So for that, it's pretty simple. Open your browser, go to Google, type EdSim. The website opens up. Right here is your free simulator. All you need to do is click it. It will get downloaded. Once it downloads, just double click on the folder. It's straightforward. Immediately will install it. The whole process won't take, I've done it a few times so you can see. This is the file. When you double click it, it'll get installed and will be ready to use. Okay people, so now that we have downloaded the EdSim simulator, I'm going to run it. What's going to open up right now is your playground. Yes, so many people get scared looking at this. You shouldn't be scared. This is where you're going to show your talent. You are the engineer. First few years of your engineering career, you will be programming. I don't know how good or bad you have been in C programming. I hope you've been nice. But nonetheless, doesn't matter. Over here, it's my responsibility to make you really good. First thing, I'm going to get you familiarized with what is here. Okay, what's there on the screen. Don't get scared. Yes, there are a lot of things. It may even look intimidating, but it doesn't matter. Many of these things you won't even use right now. You will use all of them eventually, but not right now. When you're writing your first few programs, you don't need to look at this lower side at all. This is your LCD, this is the D to A output, this is the A to D input, this is the 7-segment LED, this is your serial port output. You're not doing those programs right now. We will do programs on all of them eventually. You'll also, once I teach you a few programs, you'll yourself have the curiosity to implement programs and try these beforehand, before I even teach you. This is what happens to all your 4 ports, how the 4 ports are configured. This is where I want you to focus right now. Yes, I'm sure already you started seeing things you know. These are your registers. These are your R0 to R7. This is your operating frequency. These are timer registers, serial port registers. Great. These are your 4 port values. This is PC. It will show you how the program runs. This is any register you want to monitor. Typically in programs you want to monitor flag register, so I've written PSW. You can change this to any register you want. You write, say for example B, it will show you the value of B. Of course right now it is 0, so nothing happened. If you write SP, you know SP by default is 7. As you can see, the default value is 7. Okay, so you can see any register over here, which is very useful when you finish your program and the examiner wants to see the result. If it's an arithmetic program, they want to see what happened to the flags. They will come here and check out all the various flags. Also, if you remember, by default PSW 0.3 and 4 are 0, which means bank 0 is your default bank. You know these things, right? What is this? This is your internal RAM. Yeah, come on students, what's the size of internal RAM? 128 bytes. The addresses go from 00 to 7F. So this is 0, 0, 0, 1 all the way up to 0f, 1, 0 to 1f, 2, 0 to 2f, blah, 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 all the way up to 7f. Are you clear? So, when you do programs to add two numbers, subtract two numbers, multiply, etc., those numbers will be stored in internal RAM at different locations. How do you store? You yourself can store. Say for example, I say 20, location 20 and data value 77. See, location 20 has 77. Now, location 21 has data value, let's say 11 as an example. So 21 has 11. Let's start with our first program. Our first program will be to add these two numbers and get the result at, let's say, location 22. Of course, no carry, nothing. Our goal is first to get ourselves used to this. So let's start writing org0. I'm sure you know what this is. If you don't, no problem. Start, end. These are all assembler directives. org0 tells the assembler to start the program from location 0. You may not write this. If you don't write it, it will start the program from any free memory it has. If the examiner says load your program at location 200, write your program such that it should be at location 200. You write org 200. Basically, what you write after org, this number that you write, is the location where your program will be stored. End, of course, is used to indicate the end of the program. Start is an optional label. It's like telling the reader of the program, this is where your actual code is beginning. Sometimes you can write org followed by some code, some pre-written code where you initialize some registers with some values and then write jump to start and come to start. Anyway, those things right now will not make sense to you. It's not necessary. Start is not necessary, but it's a good habit to write and eventually will be useful when you do something before the start and then take a jump to it. You'll come to know those things when we do interrupt programming. Right now in this program, consider start as the place where you start writing a program. Now what do you want to do? You want to add the contents of location 20 and 21, store the result at 22. Come on people, this was the first program that we had done. Come on, what do you do? What's the logic? Take the data from location 20 into A. Add the value of location 21 to A. The result will be in A. Store the result at 22. Come on, let's run it. Come on, together. Move A, comma, 20h. Now, should I write hash 20h or 20h? 20h. If you write hash 20h, A will get the number 20. We don't want the number 20. We want the contents of the location 20. Add A, comma, 21h. So you took the value of location 20, you added the contents of location 21. The result is right now in A. Store the result at 22. Move 22h, comma, A. Here, S jump here. That's it. That's your program. Take the data from location 20, add the contents of 21, store the result at 22. Let's save it. Add two numbers. When you click save, it will open up the save dialog box. You can select the folder. I've written some medicine program, so I've saved it over there. Add two numbers, save the program. So you save the program. Now let's run it. All you need to do is point to the button run. Say your prayers if you're that kind of a person. Be confident about what you've done and hit the run button. That's it. We have ran the program. 77 plus 11 gave you the result 88. Did you understand this? Pause. You wanna test it? Of course. Now though I can't see you, I can pretty much feel the smile on your face. Yep, this is the first program that you've run, and this is the first of many more to come. We are going to do lots of programs. Okay, let's just enjoy this moment a little more. Location 20. Let's say you written the number 55. Okay, location 21. Let's say you have a number 33. Oh, it's going to give you the same answer. 34. Okay, so it should give you the answer 55 plus 3, 4, 8, 9. Okay, let's see. So, that's our program, and these are our inputs 55 and 34, and we press the run button and we get the answer as 89. Okay, so that's your program to add two numbers. Like I said, this is just the first of the many. Yeah, of course, your goal is to write very big programs. You begin with the smallest ones. Immediately we move to a program to add two numbers with checking for carry. Okay, now enough of playing. Let's get a little serious. Let's make this a proper exam question. In the exam, when you add two numbers, you get a sum and a carry. We've only taken care of the sum so far. We've not worked around with the carry. Let's do that also. If you remember, the first programming question that we had done, or amongst the first programming questions, was write a program to add two numbers stored at location 20, 21, store the sum at 22, and the carry at 23. So that's what we're going to do. 20 and 21. Location 20 and 21 are the places where the input numbers are stored. Our program will add these two, give you the sum at 22 and the carry at 23. So what is the trick in case you remember that program? If you don't, no problem. No problem. We will initialize a register. Let's say move R2, comma, hash 00. This is our assumed carry. If there is a carry, we will make R2 1. If there is no carry, we will let R2 be as it is. A gets your sum, correct? Move 23H, comma, R2. If A has the sum, we are storing the sum. You can write a comment by putting a semicolon and writing your comment, like how you do in a C program. Store sum from A to 22. Similarly, store carry from R2 to 23. Now, we have assumed that there is no carry by initializing R2 with the value 0. So after we have done the addition, we will check if there is a carry or not. If there is no carry, jump to the location skip. Otherwise, increment. It is not case sensitive. You can use uppercase or lowercase. I just have a habit of using uppercase everywhere, but it's no rule. Like I said, it's not case sensitive. Increment R2, and this is your label skip. That's your program. So what happens? R2 has been initialized with the value 0. You took the first number in A, you added the second number. This is where you have performed the addition, right? Now, after you perform the addition, there are two possibilities. Either there could be a carry or there could not be a carry. If there is no carry, we will directly jump to skip, which means we are doing nothing to R2. Why? Because we have assumed R2 to be 0. If there is no carry, R2 should be 0. If there is a carry, we have written if there is no carry, jump to skip. So if there is a carry, it won't obey this condition. That means it won't jump. If a program doesn't jump, then what does it do? It goes to the next location. So this particular line will only be executed if there is a carry. Only when there is a carry, R2 will get incremented. So R2 will become 1. So by the time we reach skip, R2 will be either 0 or 1. If there was a carry, R2 will be 1 and we will come here. If there was no carry, we will directly jump and come here, which means R2 will be 0. So when we reach skip, we have our result. A has the sum, R2 has the carry. A will be stored over here, R2 will be stored over here. Now, let's add two such numbers that can produce a carry. Say, for example, our numbers were FF and 0, 1. FF plus 0, 1 gives you 0, 0 as the sum and 1 as the carry. Okay, are we ready to try? Location 20 should have the value FF. What did it? Sorry. Location 20, my bad, will have the value FF. Location 21 will have the value 0, 0. Now, these two locations right now are 89 and 0. They should become 0 and 1 because the sum is 0 and the carry is 1. FF plus 0, 1. So location 21 should be 0, 1. FF plus 0, 1 should give you 0, 0 as the sum and 1 as the carry. Let's run it. Are you ready? 0, 0 is the sum, 1 is the carry. So your answer is 1, 0, 0 in all. Are you clear? Pause, reset, save your program. Always save your program. I don't need to tell you. This is add two numbers with carry. Right? Now, That was your first actual program to add two numbers, an official program to add two numbers. What will the examiner do? They'll come here, they will alter the inputs, run your program like how I did it, do it again and again till the time they're satisfied your program is correct. Of course, for such a small program, they can look at it and check. But in bigger questions, that's what they do. They alter the inputs and then they check the result, whether it works properly or not. We've just now done a program to add two numbers. Let's not stop here. We got the flow going. Let's write a program to subtract two numbers now. Ready? Ready? 50 minus 20, answer is 30. There should be no carry. Correct? What's the difference between addition program and subtraction program? Same. We have assumed that there is no carry. Carry means borrow. R2 will have it. We'll assume that there is no borrow. Take the first number, subtract the second number. So your instruction will be SUB. But problem is there is no SUB. There is SUBB, which means it will do A minus 21 minus the carry flag. My dear students, if you want to know programming, you need to first know instructions. I'm sure you've learned the videos of instructions, so you know there is no ordinary subtract, there is subtract with borrow. So those who've learned it, tell me, what have I said in that video? Since there is only subtract with borrow, before using this, always clear the carry flag to ensure that any residual carry does not interfere with your operation. So now again it will do A minus location 21 minus carry flag. But since you have cleared the carry flag, it will not make any difference. So perform the subtraction. Jump if no carry. Yeah, you're checking for borrow, but borrow is also in carry flag only. So jump if no carry, which means it will work as jump if no borrow. So if there is no borrow, skip. Otherwise, make borrow 1. So only when there is a borrow. Move A comma this and move A comma. So your sum, which is there, sum means the difference in this case, will be stored at 22. Store the difference at 22 and store the carry, which means the borrow, at 23. Suppose your numbers, let's try it. Suppose your numbers at location 20 was 50. At location 21 was 1. Okay, let's keep it 1. So what should you get? 49. You should get 4F. 50 minus 1 is 4F. Let's see, and no carry. There is no borrow. Reset. Run. 50 minus 1 is 4F and no borrow. Are you clear? So we've done two programs right now. Program to add two numbers, program to subtract two numbers. Save this. Right, add two numbers, subtract two numbers. Now, save. Let's go ahead. Let's do a program to multiply two numbers. We will take the numbers let the numbers be at the same locations, 20, 21. We will store the result at 22 and 23 such that 22 will have the lower byte and 23 will have the higher byte. When you multiply two 8-bit numbers, answer is 16 bits. So it's not sum and carry, it's lower byte and higher byte. Are you clear? ORG00, start. We don't need any carry. Let's not do this. Let's write the program. What's the code? Tell me. Take the first number from location 20. Move A, 20H. Great. Take the second number into which register? If you want multiplication, what do you know? Your multiplication works between A and B registers. Good. So move B, 21H. B came in orange color because it's an SFR. A is also an SFR, but A is a part of opcodes. If you remember my video of SFR, you know that. A is a part of opcodes. B, when you write B, the assembler will substitute 0F0 in the place of B. So whenever you write any SFR, you will get that orange color. Anyway. So A and B, you've got your inputs into A and B register from location 20 and 21. Mul AB. The name of the instruction is mul AB. So here B will not have that color because you're not using B as a register. Remember, I've told all of these things while explaining the instruction set. You don't even write mul A, B. That's an invalid instruction. It's mul AB. Anyway, you multiplied them. Answer comes in A and B. A has the lower byte, so you'll store it at 22. move 22h comma A, move 23h comma B, or 0F0, whatever you want to write. That's it. We are ready. Let's give some interesting inputs. Let's try the worst case scenario. Location 20 has FF. Location 21 also has FF. What is FF into FF? FE01. So we should get 01 over here, the lower byte, and FE over here, the higher byte. Let us see. Run. FE01. There you go. Are you clear? Are you feeling happy? Do you know how to write these programs? Do you feel you'll be able to write them by yourself? You feel you're so eager right now to practice these programs? Of course, I'm going to give you the PDF along with this video. In the PDF, all these programs will be there. First time, simply copy the program, paste it on this window. Paste it on this window and execute it the very first time you do it, so that you have a perfectly working program to try, and then erase it, try to write it by yourself, play with the code. If I'm going to teach you how to swim, I'll teach you the technique, the basic technique. Thereafter, you enter the pool, you play with the technique, you master it, you develop your own way of doing it. Same goes with this. Of course, it's far more technical than that. Not berating swimming at all. Of course, it's a beautiful talent, but this is far more technical and complicated. Every programmer eventually develops their own method or way of solving programs, or writing, tackling algorithms, tackling logics, different situations, and that is your own talent. It comes out eventually. The first thing you need to do is get a few programs running, so that you're comfortable with the interface. Let's test again. FF into 1. Now FF into 1 should give you FF with higher byte as 0. The answer is 0, 0, 0 FF. Let's see. Location 20 is FF. Fine. Location 21 is 1. Right. Let's run. Should give you FF and the higher byte as 0. Okay, keep testing as many times as you want to. You know the program is going to work. It's a correctly written code. Okay, let's save this. So this was a program to mull two numbers. Lastly, we are going to write a program to divide two numbers. Again, the same thing, same two locations, 20, 21. Instead of mull AB, you're going to do div AB, and A will have the quotient and B will have the remainder. Now, when you do FF divided by 1, FF is the quotient and 0 is the remainder. So you will get exactly the same answer, no point doing it. But suppose we do, let's do something interesting. First, let's take a normal case. Let's say location 20 contains the value 40. Location 21 contains the value 02. So 40 divided by 2, I should get 20 as the quotient and 0 as the remainder. Run. 20 is the quotient, 0 is the remainder. Are you clear? Suppose we do, save this. Suppose we do something divided by 0. Let's say location 20 has the same value 40, location 21 has the value 0. Now, anything divided by 0 is not possible. When something like this happens, your answer is a random answer, because whatever is the answer is invalid, so we call it a random answer. To tell you that the result is invalid, overflow flag becomes 1. What are your flags? Tell me. Carry, auxiliary carry, F0, RS1, RS0, overflow. Don't care, parity. So this is your overflow flag. This should become 1. Let's see if that happens. overflow flag becomes 1 to tell you that there is an overflow, which means your result is wrong. Parity flag is garbage. It doesn't matter what the value of parity flag is, because anyway the result is wrong. What is important is overflow flag becoming 1. So this is how examiners check your program, and then they ask you what happened over here. 40 divided by 40, 40 divided by 0, answer is not 40. Of course, answer is not 40. This is garbage. And that is indicated to us by overflow flag becoming 1. Are you clear? So that was your programs for add, subtract, multiply, divide. That's it for today's video. Like I said, I will be making a PDF along with this, which will contain all of these programs. Download the HCM simulator, copy these programs from the PDF, paste them, run them, then play around with the inputs, play around with the code, try to change some registers where it's possible, try to do it in your own way, get used to it, create your own questions, modify the program, play around with this. Like I said, this is your playground. When you add two numbers, you can check what happens to the flags over here, and so on and so forth. We are going to do lots of programs. Like I said, this is just the beginning. A few more things about this interface. This was a small code, so we managed to write it over here. If you're writing a real big program, which eventually we will, you can click on that U button. It unlocks this pane. Now you can write, it becomes much bigger. You can easily write bigger programs. You can even make it larger if you want to, etc. When you close this, whatever you typed over there, don't worry, it won't be lost. It'll come back over here. So nothing of your modifications will be lost. And from here, you can save your file. You can also make this entire screen bigger if you want to focus more on this and just, not really be distracted by the remaining part of the screen. You can just concentrate. If you want to concentrate here, you want to see these things clearly, you can make that bigger. You can make it smaller if you want to. And these are things you will realize yourself as you keep doing, as you keep playing with this interface more. Okay? I hope you enjoyed learning this. Wish you all the best. Do well.